Imagine an atom living in perfect harmony, much like our solar system. Electrons zip around the center just like the planets orbiting the sun. At the heart of the atomic solar system is the nucleus, comprised of protons and neutrons. These tiny particles are themselves made up of smaller units called quarks. But what holds these quarks together? Here comes gluons, the superglue of subatomic particles. They bind quarks into protons and neutrons, forming the nucleus of our atomic solar system. Now, the number of neutrons and protons are equal in a normal atom. But what if the number of neutrons or protons increases? Well, this causes the atom to become heavy in mass. And what if the mass increases? It would just want itself to be free from the extra amount of neutrons or protons. And to be free from the extra mass, it throws extra particles out in the form of alpha, beta, and gamma radiations. These radiations have different characteristics and different levels of power. And today in this video, we'll discuss about these types of radiations, how dangerous they are, and how can be they utilized for our use. The substances whose atoms are unstable, just like this one, are called radioactive substances, and they are really dangerous because anytime their atoms may decay and release radiation. While talking about alpha radiation, these are essentially helium nuclei, or simply two protons and two neutrons thrown at high speeds from the unstable atom. This type of radiation is comparatively weak and they cannot pass through our skins or even paper. Substances such as radium, uranium decays into alpha particles. Now, this doesn't mean that alpha particles aren't dangerous. Maybe holding them with bare hands isn't much hazardous, but if somehow even a tiny piece of these materials goes inside your body, it may cause severe diseases. And as the alpha radiation cannot penetrate skin, all of the radiation will be inside in your body, enough to cause fatal damage. These particles are used for medical imaging, nuclear power generation, and cancer treatment. Beta radiation usually are high energy electrons or positrons which are emitted when an unstable atom converts one of its proton into a neutron or vice versa. There are two types of beta decay, beta minus and beta plus. During a negative beta decay, one of the atom's proton is converted into a neutron. And because a proton acquires a positive charge, losing a proton for a neutral charge will cause the atom to acquire a negative charge. And to neutralize this charge, an electron as well as an antineutrino is formed and then thrown away as beta particles to avoid the atom from becoming negative. In this way, the atom achieves more stability as well as it maintains its neutral charge. During a positive beta decay, one of the atom's neutron is converted into a proton, which means that the atom now acquires a positive charge. To neutralize this charge, a positron, which is an electron's antiparticle, and a neutrino is formed and then thrown away as beta particles to conserve charge. Substances that decay into beta particles includes carbon-14, tritium, strontium-90 and radium-228. Now let's get real. Beta radiation can be hazardous. Exposure can cause radiation sickness, cancer, or even death. Beta particles can penetrate skin, causing damage to living tissues. Ingesting or inhaling beta-emitting substances can lead to internal radiation poisoning, But here's the thing, beta radiation also has some pretty cool uses. Cancer treatment. Beta emitting substances can be used to destroy cancer cells. Industrial applications. Beta radiation can be used to sterilize medical instruments, food, and even sewage. Scientific research. Beta decay helps us to understand the fundamental laws of physics and the behavior of subatomic particles. Gamma radiation, unlike the other radiations, aren't actually particles. These are electromagnetic rays and is the most powerful radiation among these three radiations. These are released when an unstable atom after its alpha or beta decay remains excited or in a high energy state, which it wants to release to stay calm and cool just as before. And it releases this extra energy in the form of gamma rays, which can not only penetrate the skin, it can penetrate the thick walls of concrete. It can be hazardous to even handle substances that releases gamma rays. Gamma radiation is emitted by substances like cobalt-60, cesium-137, iodine-131. Gamma radiation can be hazardous. Exposure can cause radiation sickness, cancer, and even death. Gamma rays can penetrate thick walls, skin, and other materials, causing damage to living tissues. Ingesting or inhaling gamma-emitting substances can lead to internal radiation poisoning. Gamma radiation also has some pretty cool uses. Just like cancer treatment, gamma-emitting substances can be used to destroy cancer cells. Sterilization. Gamma radiation can be used to sterilize medical instruments, food, and even sewage. Scientific research. Gamma radiation helps us to understand the fundamental laws of physics and the behavior of subatomic particles. That's everything about different types of nuclear decays. In our next video, we will delve deeper into the fascinating topic of nuclear physics and explore more complex topics in an easy way. To join me on this journey of unraveling the mysteries of the universe, make sure to subscribe our channel. Meet you in the next video. Until that time, bye.